Okay. Past paper questions to another 2017 paper 2 second decade B. Let me get the 2017 paper. Please give me a second, Lamai. Second decade B, I will get the question to the whiteboard. We have to, so that is a photosynthesis question. 2017 second decade B. Second question, part B. Okay. We'll discuss. You are assigned to show, okay? Because this was homework. You are assigned to show experimentally that oxygen gas is produced during photosynthesis. Oxygen gas is produced during photosynthesis. Now, if you remember, what is the equation for photosynthesis? What are the reactants? What are the photosynthesis equation? Quickly tell. Yes, carbon dioxide. And
water.
Water. What else should be there?
Light energy and chlorophyll.
Yes, light energy that we get from sunlight and chlorophyll. Good. What are the products of photosynthesis? What are the products of photosynthesis?
Glucose and oxygen.
Glucose and oxygen. Yes. Glucose is C6H12O6 plus oxygen. So when you balance, method 6 and here 6 and here 6. Now we in the photosynthesis lesson we did experiments to show that carbon dioxide is needed for photosynthesis. That water needed back experiment because we cannot cut down the water supply to a plant. Then light energy only the remember we took a leaf and then we covered a bit of the leaf using colorless glass strips. And then another part we covered with black polythene strips. And then we checked how photosynthesis has been done using a starch test. Carbon dioxide only the we just chose 2 leaves and ek leaf එක polythene bags wala gata gahua. One leaf had just water, the other leaf had KOH. So the leaf with KOH, you know, KOH absorbs all the carbon dioxide. So without carbon dioxide, it doesn't do photosynthesis. Chlorophyll ඕනද කියලා අපි බැලුවේ mosaic leaf එකක් ගත්ත croton වගේ. The green color spots, they do photosynthesis because of the presence of chlorophyll. And like white or whatever other colors, they don't do photosynthesis. A requirements ne ඊපස්සේ හැදෙන්නේ glucose. Glucose හැදෙනවද කියලා බලන්න අපි starch test එක කරන්නේ. මේ හැම එකෙමත් අපි photosynthesis උනාද කියලා බලන්නේ ඒ starch test එකම තමයි. Remember starch test again, we first took the leaf, we boiled the leaf in water to weaken the cell wall and to increase the permeability. Then we boiled the leaf in alcohol inside a boiling tube, which is inside a water bath. Can correct chlorophyll remove then the leaf would be like a pale color. Then when we put iodine, we can see clear color changes. එතකොට අපි ඇයි water වල boil කරන්නේ ඇයි alcohol වල boil කරන්නේ ඇයි water bath එකක දාන්නේ ඔක්කොම අපි කතා කරා oxygen වලට කතා කරපු එක තමයි මේකේ අපි මේකේ question එකේ අහන්නේ okay so these are the equipment and materials that we are given a beaker ඔගන්න මතකයි නම් අපි කරපු එකේ trough එකක් තිබ්බේ like a kind of a big basin, right? හැබැයි මෙතන trough එකක් නෙවෙයි දීලා තියෙන beak එකක්, but දීලා තියෙන එකෙන් අපි කරන්න ඕන. So we have a beaker. A boiling tube, glass funnel, hydrilla plant. So let's say this is my hydrilla plant. මෙව funnel එක place කරනවා. And then I have my boiling tube. ඔයගොල්ලන් මෙහෙමද ඇන්ද කියලා බලන්න. And then excuse me. And then beaker, boiling tube, glass funnel, hydrilla plant, and then water. So water is filled like this. Like this. Water is filled. So මට මතක විදිහට මේකේ marking scheme එකේ න ඒගොල්ලන් label කරපු එක එච්චර බලලා තිබුණේ නැහැ, but generally මේ වගේ when you are given the equipment and the materials as a list, better to label. අපි marking scheme එකකට frame වෙන්නේ නැතුව, without being framed to the marking scheme, it is better that we learn the most appropriate, the most correct way. හරියටම accurate විදිහටම අපි ඉගෙන ගමු. එතකොට මොන විදිහම, whether the marking scheme is flexible or whether the marking scheme is strict, it doesn't matter to us, right? අපිට කොහොමද ලකුණු හම්බ වෙනවා අපි හරි විදිහට මේක උත්තර ලියන්න ඉගෙන ගත්තොත්. So නිකම් subject matter එක දැනගත්තට විතරක් මදි ළමයි when you are doing past paper questions. In like July, August, we are properly starting the past paper revision, then you will understand it more. දැනට අපි පොඩ පොඩ කරගෙන යමු. So this is the beaker. I'm going to label everything. මේකේ marking scheme එකේ මට මත විදිහට ඒක බලලා තිබුණ නැහැ, but still we'll just learn the proper way. This is water. This is boiling tube. ඒගොල්ලන් දීලා තියෙන ටික හරිය අපි label කරමු. Glass funnel. And hydrilla plant. මේ ටික තමයි තියෙන්නේ. So write an observation that can be made when the setup is exposed to sunlight. What can you observe when this is exposed to sunlight? What did you write? What did you write? Okay, yes. Others?
Yes, bubbles are produced from the hydrilla plant.
Okay, yes. Mainly අපිට පේන්නේ gas bubbles produce වෙනවා. But I got another answer in the chat box that is also true. First of all, I will write this. Gas bubbles evolve or released from the plant. එතකොට ළමයි තව observation එකක්. මේක ලියවන හොඳටම ඇති, but another observation is as the gas is getting collected here, what do you think will happen to this water level? What would happen to the water level? When the gas is getting collected here, what will happen to this water level inside the boiling tube?
It will decrease.
Yes, it will decrease. It will go down. So that is also one observation. අපේ sensory organs වලට ඔගාන මෙතන කිව්වොත් එම oxygen gas is produced කියලා, your answer is wrong. Because observation means sensory organs වලට, your eyes, your ears, nose, tongue, skin. Whatever that your sensory organs can detect is an observation. හරිද? ඊට පස්සේ observation එකෙන් පස්සේ අපි test කරලා මේ oxygen ද මොනවාද කියලා බලන්න. When you see just some gas bubbles, you can't, I mean, ඒවා label කරලා නැහැ oxygen කියලා, you can't know whether it is oxygen or not. So observation එක අපිට පේන දේ විතරයි අපි ලියන්නේ. අපිට පේන්නේ gas bubbles are released. Or we can see water level in the boiling tube boiling tube goes down. So mainly these are the observations that we can take. Okay. How would you confirm that the gas produced during this experiment is oxygen? කොහොමද මේක අපි බලන්නේ ළමයි? හරි. glowing splinter test කියලා විතරක් ලිව්වොත් මදි. මෙතන question එක බලන්න. I mean, that answer is correct, but that is not complete. The question says, how would you confirm that the gas produces oxygen? Glowing splinter test එක කොහොමද? That is not specific enough. හරියට කියන්න ඕනේ මේකේ මොකද්ද කරන්නේ? ඒක කොහොමද වෙන්නේ? ඒ ටික හරියට කියන්න ඕනේ. So what you do is gas collect වෙච්ච එකට you introduce a glowing splinter. When introducing a glowing splinter to the tube with the gas, it will relight or reignite with the flame. මේ වගේ meaning එකක් තියෙනවා නම් ඔයාගේ answer එකට ලකුණු හම්බ වෙයි. Right? බලන්න දැන් past paper questions කරද්දී ඔයගන්ට නිකන් glowing splinter test කියලා ලිව්වොත් the answer is correct, but that is not enough. Right? And introducing a glowing splinter to the tube with the gas කියලා විතරක් ලිව්වත් මදි. Oxygen කියලා confirm කරගන්න ඔය observation එකක් ලියන්න ඕනේ. It will relight or reignite with a flame. Okay? Write down the balanced chemical equation for the photosynthesis process. දැන් අපි මෙතන ලිව්වනේ ඒකම මම මෙතන copy paste කරන්නන්නේ. ඒකම තමයි මෙතන ලියන්න ඕනේ. මේක මේ විදියටම ලියලා තියෙන්න ඕනේ. C6CO2 6H2O මේ පැත්තේ C6H12O6 and 6O2. arrow එක උඩ light energy arrow එක යට chlorophyll ඒ ඔක්කොම මේ විදියටම තිබ්බොත් විතරයි full marks හම්බ වෙන්නේ. Is this clear ළමයි? Thumbs up please if it's clear, everybody.
Yeah, teacher.
Okay, others? Yes, Metna. So light energy වෙනකොට sunlight ඉවට කමක් නැහැ. Mayumdi? Rashmika, Risindi, is it clear? Okay. 2017 done. Then 2018 second paper case C. 2018 second C. We'll see. 2018. Okay, found. That is also I gave photosynthesis. Photosynthesis වලින් තමයි ඔක්කොම දුන්නේ. Living tissues වලින් මම හිතන්නේ questions කීපයක් දෙන්න ඇති. හරි. This is 2018. Second question C. Now here again we have a photosynthesis test, an experiment that we have already learned. Let's see. The figure indicates an apparatus set up by a student for an experiment conducted with regard to photosynthesis. Okay, so we can see a glass jar and we can see a plant. We can say aqueous potassium hydroxide, KOH. Then there's light falling. Mention the aim of this experiment. What do you think is this? What is the aim of this experiment? KOH තියනවා කියලා කියන්නේ KOH වලින් carbon dioxide එක absorb කරගන්නවා. ඒතර මෙයා photosynthesis කරන්නේ නැහැ. Because otherwise everything else is here no. Water plant එකේ water තියෙනවානේ, and then light energy තියෙනවා, chlorophyll. This is a green plant, so chlorophyll is probably present. එහෙනම් carbon dioxide තමයි factor එක. KOH තියෙන හින්දා. එහෙනම් what would be the aim? Yes, to test if carbon dioxide is required for photosynthesis. මේ aim එක තමයි to test whether carbon dioxide is needed for photosynthesis. So I got all the correct answers in the chat box. Good. මේ වචන එහාට මෙහාට වෙනස් වුණාට කමක් නැහැ. Meaning should be the same. Okay. Draw a label sketch of a setup of a control experiment suitable for this experiment in the given box? This is an interesting question. කොහොමද මේක කරේ? Yes. Yeah. ළමයි control experiment එකක් කියන්නේ something like this. Now, let's say you did this experiment for the first time. කවුරු හරි scientist කෙනෙක් මේක මුලින්ම කරන්නේ නැතිනේ. Right? කරද්දී so the plant is there, it is covered with a glass jar, aqueous potassium hydroxide, light falling. Because aqueous potassium hydroxide is present, it will absorb all the carbon dioxide. So this plant will not do photosynthesis. Science is all about asking questions. Mama Hanama, are you sure? Make that. Hari. KOH carbon dioxide absorb karna hari. Habe meya photosynthesis kare natte carbon dioxide natte hinda kela what is sure? Are you sure that this plant did not conduct photosynthesis because carbon dioxide was not present? It could be anything else. මොකද හැමදේම අපිට ඇස් දෙකට පේන්නේ නැහැ නේ ළමයි. There could be other things like microorganisms or some microbial process or like something that we don't see happening. Maybe the plant has a disease. Plant එකේ මොකක් ලෙඩක් තියෙන්න පුළුවන්. මොකක් හරි දෙයක් වෙන්න පුළුවන් නේ. මෙතන carbon dioxide නැහැ කිව්වට ඒක විතරක්ම වෙන්න බෑ. It could be any other reason. I can question you like that. එහෙනම් ඔයා මේක කරද්දී තව එකක් ඇඳලා පෙන්නන්න ඕනේ මේක මේ විදිහටම හැබැයි අපි ටෙස්ට් කරන ෆැක්ට් එක තියෙන්න ඕනේ. ඔයගොල්ලෝ මතකද ළමයි අපි අපේ හැම එක්ස්පෙරිමන්ට් එකකම for an example let's say light energy කියලා. When we did the test for light energy, do you remember we took a leaf එකක් colorless polythene strip එකකින් cover කරා අනිත් එක තමයි black polythene strip එකෙන් cover කරේ. ඒතර black polythene strip එකට no light but colorless polythene strip එකට yes light. ඒතර අපිට compare කරන්න ලේසි. ඒතර we are very sure light energy හින්දා තමයි මේකේ photosynthesis වෙනවා හරි නැති හරි that is determined by the light energy present. Carbon dioxide වලටත් අපි දැන් මේ මෙතන දීලා තියෙන experiment එක නෙමෙයි we did something else in the lesson. We took a plant, leaves දෙකක් අරගත්තා equally වගේ දෙන්නටම මෙහෙම polythene bags දෙකක් දෙමු මේකට water දැම්ම මේකට KOH දැම්ම. ඇයි දෙකක් කරන්නේ? KOH වල carbon dioxide නැහැ. මෙයාගේ carbon dioxide තියෙනවා. එතකොට මේ දෙක compare කරාම මෙයා photosynthesis කරන්නේ නැහැ මෙයා photosynthesis කරනවා. May leaves dekha identical ne everything is same the only thing that is different is photosynthesis karapu නැති එකේ carbon dioxide නැහැ photosynthesis කරපු එකේ carbon dioxide තියෙනවා ඒකෙන් අපිට 100% confirm කරන්න පුළුවන් මේ leaf එක photosynthesis කරේ නැත්තේ because carbon dioxide is not present මෙතන අපිට එහෙම confirm කරන්න තව එක්කෙනෙක් නැහැ compare කරන්න ඒක හින්දා control experiment එකක් කියන්නේ that whatever the factor that we test ඒ ෆැක්ට් එක නැතුව එකක් අපි කරනවා ඒක දීලා තව එකක් කරනවා කළා බලනවා like just to confirm now මේ setup එකම තමයි අපි recreate කරන්නේ so ඔයගලන් answer එක හරි answer එක දීලා තිබ්බ ගොඩක් අය my drawings are not very good ඔයගලන් උනත් මේක perfect drawing එකක් වෙන්න ඕනේ නැහැ මෙන්න මේ setup එකම කියලා idea කරන විදිහට මෙතන draw කරා නම් හරි then the grade 11 passing batch, the ones who are writing O-levels in February, ඒගොල්ලන්ට past paper revision එක කරද්දී එක questions ඒගොල්ලන් ඇහුවා. මම ඒවත් ඔයගලන්ට discuss කරන්නම් මෙතනදී. So it's the same setup here. Instead of KOH, I put water. නැත්නම් මොනවත් නැතුව තියන්න පුළුවන්. මෙතන KOH තියෙනවා, මෙතන KOH නැහැ. No KOH. එමෙ නැත්නම් KOH වෙනුවට you can put water. Then මොකද වෙන්නේ මේ plant එකේ KOH නැහැ or water is present so carbon dioxide නැති වෙන්නේ නැහැ carbon dioxide will be there so photosynthesis will happen මෙයාගේ KOH තියෙන හින්දා carbon dioxide නැහැ so photosynthesis will not happen ඒකෙන් අපිට හරියටම compare කරලා we can be 100% sure that carbon dioxide is required for photosynthesis හරිද students ද මේකට මෙන්න මේ කඳින එකට තව මෙහෙම ඇඳලා තිබ්බා අපි ටෙක්ස්ට් බුක් එකේ ඉගෙන ගත්ත එක්ස්පෙරිමන්ට් එක ඇඳලා තිබ්බා. මෙම ලීෆ් දෙකක් තියෙනවා. මේ පොලිතින් බෑග් එකකින් මෙයා water මෙයා KOH. මේම ඇඳලා තිබ්බා. මේකෙන් අපිට පුළුවන් කන්ෆර්ම් කරගන්න yes මෙයාට කාබන් ඩයොක්සයිඩ් නැහැ so photosynthesis කරන්නේ නැහැ. මෙයාට කාබන් ඩයොක්සයිඩ් තියෙනවා so photosynthesis කරනවා. but ඒක මෙතනට ගැලපෙන්නේ නැහැ. They are saying draw a label sketch of a setup of a control experiment suitable for this experiment. අපි දැන් මේ කරන එකට suitable වෙන විදිහට control experiment එකක් තමයි අඳින්නේ. Therefore this would be the most ideal one. එක්ක KOH නැතුව තියෙනවා නැත්නම් water දානවා නැත්නම් මේ පොඩි vessel එකේ contain එක අයින් කරලා අපිට නිකන් අඳින්නත් පුළුවන්. Is that clear to you, Lamai? Please give me a thumbs up if it's clear. If not, you can ask questions. Others? Chenuli, Desindu, Evindi, Metmi, Randira, Rashmika. Hi. Then 2019 again, second B. Okay, let me get the 2019 paper. Give me a second. Second okay, B. Yeah, okay. Then light energy. Ne? Let me get this question to the whiteboard. Okay. So this is 2019 again. Second question B. A setup arranged by a student to study a factor essential for photosynthesis. This setup was kept in dark for 48 hours and then was exposed to light. And then tested for starch. To test which factor essential for photosynthesis was this setup used. What factor ka test karan api me setup එක use කරන්න ළමයි? Yes. මේක න explain කරන්න ලොකු දෙයක් නැහැ. එකක් colorless glass strips අනිත් එක black glass strips. මෙයාට light energy එන්නේ නැහැ. මෙයාට light energy එනවා. From that we can confirm light energy is present needed or not for photosynthesis. So මොකක්ද test කරන fact එක light energy. What is the reason for keeping the setup in the dark for 48 hours? Why do we keep this in dark for 48 hours? Yes. Others?
Urine starts stored in the plant.
Yes. Yeah. Others, what do you think? To remove the stored starch. Yes, correct. නැත්තම් දැන් බාන black glass strip එකෙන් cover වෙලා තියෙන තැන light energy නැතිනම් photosynthesis කරන්නේ නැහැ. But when you do the starch test, it will give positive results. Again, එතන starch තියෙනවා. ඇයි ඒ මොකද store කරපු starch තියෙන්න පුළුවන්. However, when we keep the plant in dark for 48 hours, the stored starch will be removed. So to remove the stored starch. Write the color that can be seen. Sorry. Write the color that can be seen in each of the following parts of the leaf during the test for starch. Part covered with black glass strips. ළමයි starch test එක කරද්දි මේ leaf එක අපි water වල boil කරනවා alcohol වල boil කරනවා in a water bath. ඒතර chlorophyll ඔක්කොම යනවනේ. එතකොට green color එකක් නැහැ. The leaf itself is pale. ඔයා iodine drop එකක් දැම්මම black glass strip එක තියෙන තැන starch නැති හින්දා iodine වල normal color එකම තමයි එන්නේ. Like a light brown/yellow color. Colorless glass strips තිබ්බ තැන what is the color you can see? Yeah, dark blue or purple. What about the part exposed directly to light? Yeah, dark blue or purple. මෙතන black ලියන්න එපා ළමයි. මොකද it's black color එකක් එනවා අඩුයි නේ මාර I mean black එන්නේ නැහැ. There is a bluish purplish වගේ tone එකක් තියෙනවා. So black කියලා ලියන්න එපා. It's not correct. Okay, dark blue purple වගේ color එකක් ලියන්න. That's okay. Okay, is that clear? Thumbs up. Ashwita, Evindi, Mayumdi, Metmi, Nandira, Tinura, Yashoda. Okay. Finally, 2020 के parts දෙකක් තියෙනවානේ. Let me get the 2020 paper. මම හිතන්නේ එකක් living tissues වලින් තිබ්බේ. Second එකේ yeah. 2020 second එකේ B. Let me get this question to the whiteboard. First එකේ okay, that is a good question. One second. දැන් අපි discuss කර හිටපු එකේ මෙතන part covered with black glass strip එකට no color change කියලා ලිව්වොත් is it correct? It's actually not correct. මෙතන අපෙන් අහන්නේ color change එක ගැන නෙමෙයි. Write the color that can be seen. ඔයාට පේන color එක. Color change එකක් නැහැ කියන එක නෙවෙයි. මොකද්ද පේන color එක කියලා අහන්නේ when we do the starch test. So actually there is no color change. So your answer is technically correct. හැබැයි question එකට suitable නැහැ. ඒකයි මම කිව්වේ past wave questions වලට answer කරන එක is a different art. ඒක අපි ඒකයි මම දැන් ඉඳන් පොඩ හරි questions කරන්නේ. Then you get used to that art or like the practice of doing past papers. අහලා තියෙන question එකට specifically answer කරේ නැත්නම් උගන්න ලකුණු හම්බ වෙන්නේ නැහැ. So that answer is not wrong, but it's not suitable for the question asked. Okay. Is that clear? Okay. Now 2020 second question B. We have a living tissues question. Okay. An incomplete chart indicating the classification of plant tissues is shown below. Write the tissue types relevant to the boxes A, B, C, D on the dotted lines given and complete the table. Plant tissues can be divided into permanent tissues and what is A? Okay, others, what is A? අනිත් අය මොනවද ලිව්වේ වලට? Yeah, meristematic tissue. ළමයි ඔයගොල්ලන් මම not relevant to this but mixtures part 2 එකේ PDF එකක් මම ඔයගලන්ට එවුවද? Did you get a print out of that? Did I send you? You know how my memory is නේ මට සමහරවට
Yes, teacher, you sent it.
Yeah, no ඕනේ දෙවල තියෙනවනේ. Did you all
You
get a
sent
print
it
out?
long time ago.
Really? Okay.
Yeah.
That's very surprising. මම සාමාන්‍ය එවනවා කියනවා ඉඳලා ඒ කියන්නේ ගොඩක් මිස් වෙනවා මට එහෙම එවනවා කියනවා ගොඩක් වෙලාවට. I'm surprised that I sent you. Okay, great. හරි එහෙම වුණොත් මොකද අද අපිට mixtures part 2 එකට යන්න වෙනවා. That's why we need that note. Anyways. Then permanent tissues can be divided into simple permanent tissues and what is B? Yes. Complex permanent tissues. Then simple permanent tissues, there are 3 types, parenchyma, collenchyma, and what is C? Others, what is C? Yes, sclerenchyma. Then complex permanent tissues, there are 2 types, xylem and what is D? Phloem. මම කියලා මේවා අමතක වෙන්න දෙන්න එපා. නිතර questions මොන හරි කරන්න. මම ඔයගන්ට කිව්වනේ ඊට MCQ quiz එකේ කතාව. Did I tell you? So yeah, සමහර අයට කියන්නේ නැත්තේ මම maths class එකේ මම හිතන්නේ කිව්වා, but this is not relevant to maths, it's actually relevant to science. There will be an MCQ quiz. මම ඔයගලන්ට link එක ගෙවන්නම් අපේ website එකේ තියෙනවා. It's open for everybody. ඔයගලන් use කරන්න, ඔයගලන්ගේ යාළුවෝ කැමති කට්ටියට යවන්න පුළුවන්. Lesson by lesson O level past paper වල MCQs වලින් quiz එක තියෙන්නේ. So you just have to like click on the correct answer, and at the end you get the marks for the quiz. So මම හිතුවේ ඔයගලන්ට like සමහර දේවල් it's better to do it like a game sort of, you know, ගොඩක් වෙලාවට in other countries education is not as boring as in Sri Lanka. So they have like used different methods, easy methods to like make studying easier and more fun and interesting. So ඒකින්ද මං හිතුවේ එහෙම MCQ quiz එකක් launch කරන්න. ඒක කොහොමත් ඔයගලන්ට next week වගේ වෙද්දී ඊට කලින් පුළුවන් වෙයි. Next week මේ week එකේ end වෙද්දී lessons කීපයක් දානවා. So living tissues photosynthesis ගොඩක් දුරට Monday Tuesday දවස් දෙක ඇතුළත යයි. ඒතර මම ඒව ටික ඔයගලන්ට link එක එවන්නම්. ඒත් ඔයගලන්ට website එකට ගිහිල්ලා බලන්න පුළුවන් කෙලින්ම. And have you all heard of something called flashcards? How the flashcards කියන එක අහලා තියෙනවා. Have you all heard of flashcards? No? Okay. එහෙනම් that is for another day. The flashcards එක තාම මොනවත් අපි මේ පටන් ගන්න නැහැ. MCQ quiz එක තමයි mainly focus කරලා තියෙන්නේ, but
Yes,
flashcards
I have heard about it.
yes, it is a learning aid. ඒ කියන්නේ ඔයගලන් දැන් හිතන්නකෝ ඔයගලන් පාඩම් කරන් එනවා මම ප්‍රශ්න අහනවා කියලා. ඒ වෙනුවට card එකේ like for one lesson there is a pack of cards. ඕක සාමාන්‍යයෙන් ගොඩක් අය පාඩම් කරද්දී physically හදනවා. කොළ කැලි ටිකක් හරි cards ටිකක් හරි අරගෙන හැම card එකෙම questions ලියනවා. ඊට shuffle කරලා just drawing one card, again a question එකට answer කරනවා, then another card, then you answer likewise. It's like an interesting way to study and to see if you remember. මොකද ඔයගලන් දැන් grade 11 මුල කාලේ ඉන්නේ. So මේ කාලේ now you have a good memory of living tissues, you have a good memory of photosynthesis, and you will have a good memory of mixtures because we'll be doing it today and we did a part of it last week. එතකොට ඒක නිතරම revise කරනකොට ආයෙ අලුතෙන් පාඩම් කරන්න ඕනේ නැහැ. ඔයගලන් හිතන තරම් ලේසි නෑ ආයෙ දෙයක් brand new පාඩම් කරන එක. So better to, you know, keep it always revised. يعني class එකේ අපි කරන ටික ඔයගලගේ මතකේ තියෙනවානේ. ඉතින් ගෙදර ගිහලා චුට්ටක් ඕක go through කරගන්නවා. And then there should be some way that you can constantly revise. Maybe like doing some MCQs, maybe like using some flashcards or any other way. But whatever I can do to help you study, I will do from my end. So MCQ quiz එකයි flashcards එකයි ඒකයි මම flashcards එක නම් කොහොමද මේ month end වගේ වෙයි. But MCQ quiz is done. So I just have to upload the questions. I will upload and send you. ඒක ඕන කෙනෙක්ට use කරන්න පුළුවන්. As I said, not just for class students. ඒතර ඔයගොල්ලෝ use කරලා යාළුවන්ටත් යවලා use කරලා බලලා මට කියන්න whether you all like it or not. Okay? හරි. Roman number 2. What is the type of tissue in which photosynthesis occurs most? Where the photosynthesis වෙන්නේ? Parenchyma. That goes without saying. Parenchyma වල මොකද කොහොමද meristematic වල නෑනේ. meristematic වල ඒගොල්ලන්ගේ main function එක just actively dividing using mitosis. They don't even have chloroplasts. Permanent tissues වල simple permanent tissues වල parenchyma. If you remember parenchyma වල there are spongy mesophyll layer and palisade mesophyll layer. ඒ දෙන්නගේ හොඳට chloroplasts තියෙනවා, that those will do photosynthesis. Collenchyma වලත් තියෙනවා photosynthesis, they also do, but it's not their main function. So answer is parenchyma. Name the type of tissue which contains sieve tube elements. Let's see my question again. Phloem, yeah. මොනවාද phloem tissue එකේ තියෙන other tissue types? Okay, sieve tube elements. What else? Sieve tube elements. What else? Phloem එකේ මොනවද වෙන තියෙන්නේ? Companion cells. Remember, sieve tube elements වලට nucleus එකක් නැහැ. ඒකින්ද යාගේ activities control කරන්න තමයි companion cell එක ඉන්නේ. Sieve tube element is just transports food. Companion cell is there to control the activities of the sieve tube element. What else? Phloem fibers. Phloem fibers give the support. And yes, phloem parenchyma. Phloem parenchyma වලින් කරන්නේ mainly food storage. In the phloem tissue, sieve tube element, companion cell, and phloem parenchyma, all three of them are living. Only phloem fibers are dead. In the xylem tissue, what are the four types of tissues? Xylem. Quickly. Unmute කළා හරි කොහොමද කියන්න ටක් ගාලා. Xylem vessel element. Xylem vessel element එක කරන්නේ transporting water and minerals. Then tracheids. Tracheids වලිනුත් කරන්නේ transporting water and minerals. What else? Xylem fibers. Xylem fibers වලින් කරන්නේ giving the strength and support. Then parenchyma, food storage. In the xylem tissue, xylem vessel element, tracheids, and xylem fibers, they're all dead. The only living one is xylem parenchyma. ඒක මතක තියාගන්න MCQ වල හැම living dead දාන්න පුළුවන්. Okay, so this is the B part. I hope that's clear. Let's move on to the C. ආයෙත් අපිට oxygen ගැනමයි නේ තියෙන C එකේ. Let me get the C part to the whiteboard. An apparatus set up by a group of students to investigate a product of photosynthesis is shown in the diagram. What is the gas collected in the test tube when this apparatus is kept in sunlight? So we have a hydrilla plant, glass funnel, api dannaane me experiment එක. So what is the gas collected in the test tube, lamai, when we keep this in sunlight? Oxygen, yes, because oxygen is produced during photosynthesis. State a test that can be done to identify that gas and the observation. Test එක මොකද්ද observation එක. What is the test and what is the observation? Yes, again something that we discussed a little while ago, right? Test එක මොකද්ද? මෙතන observation එක ලියන්න වෙනම තැනක් තියෙනවා. So, test එක තමයි inserting a glowing splinter into the test tube. What is observation? It relights or reignites with a flame. මෙච්චරයි answer එක. ඉතින් මේක ඔයගලන් වචන එහාට මැද කරාට කමක් නැහැ, but the answer, the idea should be the same. මෙතන it reignites නැත්නම් relights කියන වචනේ තියෙන්න ඕනේ. Because glowing splint එකක් ගත්තොත් එම්ම මෙහෙම glow එක විතරයි තියෙන හඳුන් කුරක් වගේ. Relights or reignites means ඒකේ flame එක ආයෙ එනවා අලුතෙන්. අලුතෙන් කියන්නේ අර තිබ්බ flame එකක් තියෙන flame එකනේ අපි නිවන්නේ හඳුන් කුරක් වුණා. Then there's only the glow. But if you introduce it into oxygen gas, it will get the flame back. That's why we say relight or reignite. A new apparatus similar to the above apparatus was made by putting water saturated with carbon dioxide gas. ඒ කියන්නේ වැඩිපුර carbon dioxide හොඳටම maximum තියනවා එකේ. Saturated with carbon dioxide gas. Normal water use කරන්නේ නැතුව we are using water that is saturated with carbon dioxide gas. Okay. එතකොට state an observation that could be expected with regard to the evolution of gas bubbles in the new apparatus when comparing with the evolution of gas bubbles in the first apparatus under similar environmental conditions. What do you think? Gas bubbles ගත්තොත් එහෙම කලින් එකට වඩා දැන් එකේ gas bubbles evolve වෙන විදිය ගැන what can you say? What did you write? Now ළමයි මේ water වල carbon dioxide වැඩි ඉන්නේ නම් කලින් අපි use කරලා තියෙන normal water. Now in this new apparatus, we are using water saturated with carbon dioxide. Saturated with carbon dioxide means there is more carbon dioxide. And you know carbon dioxide is one of the main reactants. It is required for photosynthesis, right? So carbon dioxide වැඩි කියන්නේ photosynthesis වැඩියෙන් වෙනවානේ. Carbon dioxide වැඩි because carbon dioxide is needed for photosynthesis නේ. Carbon dioxide වැඩි කියන්නේ photosynthesis වැඩියෙන් වෙනවා. Photosynthesis වැඩියෙන් වෙනවා කියන්නේ what is the product? Oxygen. More oxygen gas will be produced. So in terms of gas bubbles, what you can say is that gas bubbles will evolve faster. Will evolve faster. Or more gas bubbles will evolve. And ඒ වගේ idea එකක් දෙන විදිහට answer එක ලියුවා නම් you get marks. Did you all write something like this, ළමයි? Any different answers that you all wrote? මේ ඇරෙන්න වෙන විදිහ answers ලියපුවා ඉන්නවද? කමක් නැහැ. Visible කියලා කිව්වට කම නැහැ. කියන්නේ more gas bubbles are visible වගේ නේ? Okay, that's okay. What else? Any other answers? I hope you understand the question now. Carbon dioxide වැඩි කියන්නේ photosynthesis වැඩි. ඒතර oxygen gas එක වැඩියෙන් හැදෙනවා. ඒතර මෙතන හරිය observation now. You can't write more oxygen gas will produce. මොකද අපි gas bubbles දැක්කම we don't know whether it's oxygen no. Observation is we can see more gas bubbles. What is the reason? Because more carbon dioxide is present, rate of photosynthesis. Because photosynthesis is a chemical reaction, lamai. ඔගන්න මතකයිද rate of reaction lesson එකේ අපි කිව්වා I mean rate of reaction එක අපි කතා කරා how what affects the rate of a reaction. දැන් මෙතන carbon dioxide වැඩි කියන්නේ rate of reaction වැඩි. So photosynthesis is a reaction. Rate of photosynthesis will be faster. Therefore, more oxygen gas will be produced. මෙන්න මේ වගේ තමයි answer කෙරෙන්නේ. Is this clear, Lama? Did you all understand? Can you all give me a thumbs up if you understood? If not, let me know. Ashwita, Mayumdi, Metmi, Risin, Rashmika, Tinura, Yashoda. Okay. I think that is all, no? Echaran apne tiyenne homework. So we will go back to the question, the lesson. Hari factors affecting solubility. Well, we finished temperature. Give me a second. Mata solubility karanna values ටිකක් වුණා. And Hari. Number one, so factors affecting solubility. Well, number one, temperature. Put number two and write nature of solute. Number two, Kaliana, nature of solute. Nature of the solute. We are back to our lesson, huh? Nature of the solute. Okay. Now here, listen to this very carefully. We are going to take 3 beakers, just like in the previous one, temperature වලදී අපි තුනක් අරන් compare කරානේ. අපි කොහොමද ඒකේ ලිව්වේ? Let me get that and see. Okay. අපි තුනක් අරන් compare කරානේ. Okay. So මෙතනත් අපි තුනක් අරන් බලනවා, right? So we have 3 beakers. like this. මේකේ තියෙන මේ තුනේම තියෙන water. තුනේම water තියෙන්නේ. මෙයාට මම දානවා NaCl. Temperature, all of these are at 25 degrees Celsius. All of these are at 25 degrees Celsius. And this is all water, 100 grams. Mithunama water, 100 grams. Okay. So make it mama danava NaCl. Diya kara balana. Balana kota I can see the maximum mass of NaCl that dissolves in 100 grams of water at 25 degrees Celsius is 36 grams. Then make it mama dissolve kara balanava magnesium chloride. Dissolve baladi, I can see that the maximum magnesium chloride that dissolves in 100 grams of water at 25 degrees Celsius is 53 grams of magnesium chloride. Then make it a mama diakana potassium sulfate. Balano, I can see the maximum mass of potassium sulfate that dissolves in 100 grams of water at 25 degrees Celsius is 12 grams. Now, balanna solubility gato, the solubilities are different now. In the first one, it's 36 grams. In the second one, 53 grams. In the third one, it's 12 grams. As solubility venasune. You can see the temperature is the same. Here the temperature is 25 degrees Celsius, here 25 degrees Celsius, and here 25 degrees Celsius. So the temperature is the same. Solvent is also the same. Water, water, water. The amount of solvent is also the same. May I get 100 grams, may I get 100 grams, may I get 100 grams. Balanna metanna thune venas vela tiyenne the solute, right? Here the solute is NaCl, here the solute is MgCl2, here the solute is potassium sulfate. Because the solute was different in the three instances, everything else was constant. Only the solute was different. Therefore, solubility is different in the three instances. Is that clear, Lamai? Give me a thumbs up before we start to write. Okay. Then solubility statements, they are not pidandavane. I have some questions. Yes, Metna. 25 degrees is the temperature of water. Temperature of water again, temperature of this system. Water maneve, my system make a temperature 25 degrees Celsius will maintain karagena thapi karane. Tune. So yes, it is technically water, the temperature of water. Explain it again. Yes, for sure. 1 second. Here we can see it's the same solvent. Water 100 grams, water 100 grams, water 100 grams. And also we can see it's the same temperature, 25 degrees Celsius, 25 degrees Celsius, 25 degrees Celsius. Happy me tunde na the solubility ke venas ne. Here 36 grams solubility, here 53 grams is the solubility, here 12 grams is the solubility. Why are the solubilities different? Because the solute is different. Metana solute ke NaCl, metana MgCl2, metana K2SO4. Everything else is the same in the three instances except for the solute. Solute ke venas hinda, the solubility becomes different. Is that clear? Okay. හරියද හැමෝටම? මම ප්‍රශ්න තියෙනවා නම් අහන්න ළමයි ආ. දැන් solubility statement එක ලියන්න අපි දන්නවනේ මම එකක් ලියලා පේනවා ඊටු ටික තනිය ලියන්න. Solubility statement එක ලියද්දි you must mention temperature here at 25 degrees Celsius. මගේ degree mark එක ඇත්තට ආවේ, but you know how to put the degree mark නේ. At 25 degrees Celsius, solubility of NaCl in water is 100 grams. මෙතන sorry 100 grams with 36 grams. water වල mass එක කියන්න ඕනේ නැහැ මොකද ඔයගලන් දන්නවා solubility කියද්දි කොහොමත් solvent should be 100 grams. When you are writing solubility anyways the solvent should be 100 grams නේ. ඒකින්ද solvent එක කොච්චර mass එකක්ද කියලා කියන්න ඕනේ නැහැ. At 25 degrees, solubility of NaCl in water is 36 grams. Likewise, you can write the solubility statement for these as well. And then, අපි යටින් පොඩි statement එකක් ලියමු. ඔයගොල්ලෝ ලියන්න පටන් ගන්න ළමයි. Start writing. Number 2 කියලා දාලා, nature of solid කියලා දාලා මේ ටික ඇඳලා ලියන්න. Quickly write this ළමයි. While you write this, give me a second. එතකම් මේක ලියලා මේ ටික ඇඳලා මේ ටික ලියා ගන්න. මේ දෙකටත් solubility statement එක ලියන්න. Done, ළමයි? Who needs more time? මට මේක time එකක් තියන්න බැරි වුණා, but who needs more time? Solubility statements ටික ලියන්නම් බලන්න ඔයගොල්ලන් හරියට ලියලාද කියලා. මෙතන at 25 degrees Celsius, solubility of MgCl2 in water is 53 grams. Then මෙතන same thing, only the values are getting different. At 25 degrees Celsius, solubility of K2SO4 in water is 12 grams. හරිද ළමයි? Who needs more time? Shall I move on? Okay, let's move on. Third factor is ළමයි nature of solvent. දැන් මුකුත් ලියන්න එපා. හොඳට අහගන්න මුලින්ම. අහගත්තට පස්සේ ලියමු. So, මෙතන මම කරන්නේ මෙන්න මෙහෙම දෙයක්. Right? Here I'm gonna take again 3 instances like this. Beakers තුනක් ගන්නවා. I have solvents. Now this is at 25 degrees Celsius. Everything else is also going to be the same temperature. Like this. And like this. මේ තුන මෙයාට දාන්නේ solute එක අපි දාමු copper sulfate. මෙයාටත් solute එක දාන්නේ copper sulfate. මෙයාටත් solute එක දාන්නේ copper sulfate. Now the temperature is the same. Solute is also the same. Now the solvent is what is different. Okay, solvent එක තමයි වෙනස්. මෙතන solvent එක water 100 grams. දෙවැනි එකේ solvent එක අපි දාමු liquid ammonia. Ammonia gas එකේම liquid version එක. Don't worry about the solvent too much. Just get the idea only. Liquid ammonia, again I am getting 100 grams. Third එකට අපි ගමු ethanol. Ethanol is an alcohol solution in the lab. ekenot 100 grams. Now here the solvents are different. Temperature is the same, solute is the same, but solvents are different. එතකොට බලන්න solubility කොහොමද වෙනස් වෙන්නේ? Copper sulfate solubility in water at 25 degrees Celsius is 32 grams. Copper sulfate solubility in liquid ammonia at 25 degrees Celsius is, for an example, 8 grams. Copper sulfate solubility in ethanol at 25 degrees Celsius is 0.1 grams. You can see that the solubility values are significantly different. I different වෙලා තියෙන්නේ. Temperature එකත් එකයි. Solute එකත් එකයි, but what is different here? Solvent is different. Solvent එක වෙනස් නිසා solubility එක වෙනස් වෙලා. So you can write the solubility statements for each. At 25 degrees Celsius, solubility of copper sulfate in water is 32 grams. Likewise, what අනිත් කට්ටියගේ solubility ලියන්න පුළුවන්. At 25 degrees Celsius, solubility of copper sulfate in liquid ammonia is 8 grams. And here also you can write. So from this, it's very clear for us that nature of solvent also affects the solubility. ඔගොල්ලෝ ලියන්න පටන් ගන්න ළමයි. මේක තේරුණාද? Give me a thumbs up if you understood. Okay, start writing. Quickly write, huh? මම දෙන්නම් මේකට 5 minutes. Make it fast. Done writing, Lamai? Thumbs up, please. Others? Okay. So those are all the factors that affect solubility of a solute. We talked about temperature, we talked about nature of solute, and we talked about nature of solvent. Hari, now when we talk about solutes and solvents, there are different types. For this, I'm going to take a classification that is straight away on the textbook. I'll make a screenshot because no point in trying to draw this again. So solutes and okay. For an example, let's say now you know sugar or let's say salt. Salt dissolves in water very well. But if you try to put some salt into coconut oil, it doesn't dissolve well. It doesn't dissolve. Then if you take for another example, let's say grease. Grease wage ekak වතුර වලින් අයින් කරන්න බෑ. So you will have to use like oil or something. So සමහර අයගේ විතරයි dissolve වෙන්නේ. Not everything dissolves in everything. If you take now heterogeneous mixtures wala, when you put coconut oil and water, they don't mix well. But if you put alcohol and water, they mix really well. Likewise, different solutes and solvent mix in different ways to make either homogeneous mixtures or heterogeneous mixtures. So, this is very simple. Don't try to think about it too much. Make a main concept මුලින්ම solutes and solvents can be divided into two as organic and inorganic. What is organic? In grade 10, in the very first lesson, we learned what organic means. What is organic?
They contain carbon.
Yeah. Very
It
good.
contains
Organic. Yes. Yeah. Carbon. It contains carbon. Organic compounds contain carbon. What about inorganic compounds?
compounds that do not contain carbon.
But they also have exceptions.
Yes, there are exceptions. Yes, inorganic compounds are compounds that do not contain carbon. However, there are some exceptions. Carbon dioxide, carbon monoxide, certain carbonates and bicarbonates. මේවට carbon තිබ්බට ඒක inorganic. Otherwise, everything else that have carbon, they are organic. Things that don't have carbon, they are inorganic. In both organic and inorganic solutes and solvents, we can categorize them as polar and non-polar. Then මම දන්නේ ඔයගොල්ලන්ට මතකයිද polar non-polar කියලා, but nevertheless I will discuss it again. Do you remember we talked about polarity in grade 10? අපි කිව්වා if you take something like HCl. HCl කියන්නේ covalent compound එකක් කොහොමද හැදෙන්නේ? Hydrogen and chlorine, they form a covalent bond like this. ඔහොම තමයි තියෙන්නේ Lewis structure එක. You know covalent bond එකක් හැදෙන්නේ කොහොමද? When two electrons are shared. So hydrogen electron එකකුයි chlorine electron එකකුයි මෙහෙම share වෙලා ඉන්නේ. Or will they be closer to one atom? What do you think? Maybe which one has a higher electronegativity? Come on, Lamai. Hydrogen and chlorine gathama, which one has a higher electronegativity? higher electronegativity, වැඩිම electronegativity, the higher one. මතක නැද්ද grade 10 ඒවා? Structure of matter lesson එකේ අපි කතා කරා first ionization energy, we talked about electronegativity. Yes. Anybody? Yeah. Chlorine. Chlorine has a higher electronegativity than hydrogen. සාමාන්‍යයෙන් අපි period එකක මේ පැත්තේ left නෙවෙයි right side එකේ ඉන්න කට්ටියගේ electronegativity වැඩි, left side එකේ ඉන්න අයගේ අඩුයි. What is electronegativity? Do you all remember what is electronegativity? What is electronegativity? Ability to attract electrons in a bond. Now, chlorine has a higher electronegativity than hydrogen. ඒකින්ද මේ bond එකේ electrons දෙන්න මේ විදිහට perfectly balance වෙලා ඉන්නේ නැහැ. These two electrons will be closer to the chlorine atom. Why? Chlorine has a higher electronegativity. මේ electrons දෙන්න මෙහෙම නෙවෙයි ඉන්නේ. Very closer to chlorine. Since the two electrons are very closer to chlorine, electrons are negatively charged. Chlorine to partial negative charge එකක් එනවා. This is not an actual negative charge. මොකද මේ electrons එක ගැලවිලා chlorine ට ඇවිල්ලා නැහැ. They are just closer to chlorine. So it gets a partial negative charge. Compared to that, hydrogen has a partial positive charge. මෙන්න මේ වගේ charge separation එකකට තමයි අපි කියන්නේ polarity කියලා. So since there is a charge separation here, this is a polar molecule. Is that clear, Lamai? Thumbs up, please. Hydrogen and chlorine after there's a covalent bond. Yes. Covalent bond. Then from hydrogen and chlorine, chlorine has a higher electronegativity. That means it attracts the electrons in the bond towards itself. So electrons are negatively charged. So chlorine gets a partial negative. Relative to that, hydrogen gets a partial positive. So we call it polar. If you take the chlorine molecule, chlorine atoms දෙකකින් හැදිලා තියෙන්නේ. Here also there are two electrons like this. Metal lamai, I mean chlorine has a certain electronegativity, but both chlorines have similar electronegativity. දෙන්නම chlorine. දෙන්නම chlorine කියන්නේ දෙන්නගම electronegativity එක එකයි. එතකොට මොකද වෙන්නේ? දෙපැත්තෙන්ම attract කරන එකම විදියට. හිතන්න කඹ අදින තරඟයක නම් teams දෙකම එකම force එකෙන් කඹේ ඇද්දොත් එimhe දෙපැත්තටම කඹේ යන්නේ නැහැ, right? Tug of war. So ඒ වගේම තමයි here දෙන්නම attract කරන්නේ එකම force එකෙන්. So electrons දෙන්න දෙපැත්තටම යන්න නැතුව මැද balance එකේ ඉන්නවා. ඒකින මේ වගේ කට අපි කියනවා මෙතන polarity නැහැ. So this is non-polar. So polar non-polar කියන්නේ ඒකයි. So if you take organic solutes or solvents, there are some which are polar, there are some which are non-polar. Polar වලට examples ගොඩක් තියෙනවා. Alcohol, formalin, acetone. මේ ඔක්කොම මතක තියාගන්න ඕනේ නැහැ. එකක් වගේ මතක තියාගන්න. එකක් හරි දෙකක් හරි. Organic solutes or solvents වල non-polar කට්ටිය ඉන්නවා. Hexane, benzene and carbon tetrachloride. Inorganic වල polar කට්ටිය water, ammonia and hydrogen chloride. Hydrogen chloride is this. Inorganic වල non-polar carbon disulfide and liquid carbon dioxide. ඒ කියන්නේ ළමයි හැමලේම solutes and solvents, they can be classified as organic and inorganic, and they can also be classified as polar and non-polar. Then why did we start talking about this? Because we were wondering, සමහර කට්ටිය සමහර අයගේ dissolve වෙන්නේ, but සමහර අය dissolve වෙන්නේ නැහැ. Water, alcohol dissolve වෙනවා, but water, coconut oil dissolve වෙන්නේ නැහැ. Salt, water dissolve වෙනවා, but salt, coconut oil dissolve වෙන්නේ නැහැ. ඒ වගේ dissolve වෙන විදිහ හරි වෙනස්. ඒ කොහොමද වෙන්නේ කියලා බලන්නයි අපි මේක කතා කරන්නේ. I'll tell you why. Anything ළමයි organic ද inorganic ද කියන එක අපිට ලොකුවට අදාළ නැහැ in our syllabus. Organic වුණත් inorganic වුණත් වැඩක් නැහැ. What is important is whether they are polar or non-polar. හැම වෙලේම ළමයි polar කට්ටිය dissolve වෙන්නේ polar කට්ටියගේ. Non-polar අය dissolve වෙන්නේ non-polar අයගේ. For an example, if you take water මොනවත් ලියන්න එපා. I'm going to give a separate note for this. Water is polar. Coconut oil is non-polar. Then දෙන්න වෙනස්නේ. Water is polar, coconut oil is non-polar. ඒ කියන්නේ ඒ දෙනා dissolve වෙන්නේ නැහැ. Okay, දෙනා dissolve වෙන්නේ නැහැ. Salt is polar. Salt is polar, water is polar, both are polar, so they dissolve well. Salt is polar, coconut oil is non-polar, again they don't dissolve. Grease is non-polar. Grease කියන්නේ මොනවද කියලා දන්නවනේ. ඔය machines වල එහෙම තියෙන grease. Grease is non-polar. Kerosene කියන්නේ ළමයි භූමි තෙල්. That is also non-polar. ගොඩක් වෙලාවට machines වල එහෙම grease අයින් කරන්න ඕන නම් භූමි තෙල් වලින් තමයි අයින් කරන්නේ. Why? Grease is non-polar, kerosene is non-polar, therefore grease and kerosene dissolve well. Grease is non-polar, water is polar, therefore they don't dissolve well. ඒ වගේ හැම වෙලෙම ළමයි organic ද inorganic ද කියන එක වැඩි අදාළ නැහැ. අපිට important polar ද non-polar ද කියන එක. Always polar solutes dissolve in polar solvents and non-polar solutes dissolve in non-polar solvents. හැම වෙලෙම polarity එක වගේ කට්ටිය තමයි dissolve වෙන්නේ. Soap is polar. Soap is polar. මොකද soap වල මෙහෙමයි. Soap වල polar ගතියට වැඩි. ඒ කියන්නේ if you take soap වල mainly තියෙනවා sodium hydroxide. This is polar. ඊට අමතරව soap හැදිලා තියෙනවා plant oil වලින්. Plant oils උත් තියෙනවා soap වල. Oil non-polar. So එහෙම part එකකුත් තියෙනවා. හැබැයි sodium hydroxide වැඩියෙන් තියෙන ඉඳ it is polar. Plant oils උත් තියෙනවා. ඒතර non-polar පොඩ්ඩක් තියෙනවා. But polar ගතිය වැඩි හින්දා හොඳට වතුරත් එක්ක dissolve වෙනවා. Okay? So did you all understand that? Lama, can you all give me, excuse me for like 2 minutes? Oh, minna, මොනවත් ලියන්න එපා. Wait. Okay, ළමයි. Excuse me. Okay. අපි ලියමු. Give me a second. මෙන්න මේ classification එක චුට්ටක් ඇඳගත්තොත් හොඳයි. Let me erase all of this. I will give you a subtopic. අපි මේකට දාගමු පොඩි subtopic එකක් දාගන්න. Solubility of solutes/solvents. කියලා subtopic එකක් දාගන්න. මාත් එක්කම ලියන්න ළමයි, then we can save time. Very rapidly ලියන්න ළමයි. I hope you are writing with me. මට මේ දැන් මතක් වුණේ soap කතන්දරය කියද්දී it's kind of interesting දෙයක් තමයි මම ලියන ගමන් කියන්නම් ඔයගලන්ට. දැන් soap වතුරේ දිය වෙනවනේ of course when we take a body wash we use soap to clean our body and then we go under the shower and we wash the chart එක ඇඳ ගන්න මේ examples ටික නම් ලිව්වේ නැති වුණාට කමක් නැහැ. එක example එකක් විතරක් ලිව්වත් ඇති. alcohol, formalin, acetone ඔක්කොම ලියන්න ඕනේ. එකක් වගේ ලිව්වා නම් ඇති හැම එකටම. So as I was saying soap වලින් ඇඟ හොදලා වතුර වලින් wash කරනවානේ. So soap dissolves in water. That is because as I said soap වල දැන් මම ඉස්සර ඔයගන්ට කිව්වේ කොහොමද කොහෙද කිව්වේ. චුට්ටක් මේක ලියන එක නවත්තලා අහන් හිටියත් කමක් නැහැ. It's kind of interesting. It's good for general knowledge also. Soap හැදිලා තියෙන NaOH තියෙනවානේ. So NaOH is polar. NaOH is polar and water is polar. Therefore soap dissolves in water. හැබැයි ඔයගොල්ලෝ notice කරලා තියෙනවද හිතන්න අතේ oil තියෙනවා කියලා? අතේ තියෙන oil සබන් වලින් හේදුවාම හොඳට හේදිලා යනව නේද? ඒක experience කරලා තියෙනවද? මට ඒ වෙලේ දැන් ඒ වෙලේ මම අර පොඩි වෙන වැඩකට ගිහින් මට ඒ වෙලේ එක මේ කතා කරන්න අමතකුණා. but ඒක කාටද හිතුණාද? soap ගැන කතා කරද්දී if soap is polar, how does soap wash coconut oil? ඔයාගේ අතේ coconut oil හරි මොහරි oil එකක් තියෙනවා සබන් දාලා හොදුවම හොඳට යනවා. ඒක තමයි. ඒක තමයි that is interesting. No ඒකේ වෙන්නේ මම ඔයගලන්ට කියවන්නද soap හැදලා තියෙන NaOH which is polar but soap also හැදලා තියෙන plant oils වලින්. plant oils are non-polar. So soap වතුරත් එක්ක ඉන්න වෙලාවට soap ගේ polar පැත්ත තමයි වැඩියෙන් ඉන්නේ. Okay? So එතකොට now let's say you wash your hands with soap and then you wash it with water. So it dissolves well in water. එතන වෙන්නේ NaOH, which is the polar part, becomes more active. Let's say you have coconut oil in your hands and you wash your hands with soap. ඒ වෙලේට coconut oil is non-polar නේ. ඒ වෙලේට soap වල active වෙන්නේ මේ non-polar part එක. So non-polar part එක වැඩියෙන් active එතකොට soap වල, which is made of plant oils. ඔතන තියෙනවා කතාවක් hydrophilic, hydrophobic එහෙම කියලා. ඒක ඔයගලන්ට ටිකක් it will be a bit complicated. So in very simple terms, soap has two parts. It can also be polar, it can be non-polar as well. Is that clear? ඒකයි ආ polar non-polar දෙකේම කට්ටියත් එක්ක interact කරන්නේ. Met me since you asked that question and others, is that clear? Yeah. Okay, හරි. මේක continue කරන්න ලියන එක. So ළමයි textbook එකේ තියෙන example එකක් මම මෙතන මේ තව ලියනවා. You know කොස් කාලා තියෙනවා නම් සහ ගෙදර කොස් හදනවා නම් you know කොහොල්ල right? කොහොල්ල කියන්නේ අර jack glue කිව්වද දන්නේ නැහැ නේ කොහොල්ල දන්නේ නැත්නම්. මොකද මගේ වෙන ක්ලාස් එක ළමයි කොහොල්ල කියන්නේ මොනවද කියලා දන්නේ නැහැ කියලා කිව්වා. කොහොල්ල දන්නවද ඔයගොල්ලෝ? දැන් නැති අය ඉන්නවද? I'm not going to judge. Then I'm not going to judge because some of you might not know. Yes. කොස්ගෙඩිය cup. ඒ කියන්නේ ගොඩක් අය yes sticky thing එක yes. ඒ කියන්නේ ගොඩක් වෙලාවට කපපු කොස්නේ දැන් ගන්න ගෙවල් වල කියන්නේ කපපු කොස් අරන් හදන නැත්නම් දැන් ගොඩක් ගෙවල් නෙවෙයි සමහර ගෙවල් වල කොස් උයනවා අඩුයි. උයනවා හරි තම්බනවා හරි අඩුයි. සහ දැන් ගොඩක් ගෙවල් වල අර already කපපුවා කඩෙන් ගන්නවා. කඩෙන් හරි කොහෙන් හරි ගන්නවා. හැබැයි සාමාන්‍යයෙන් කොස් ගෙඩියක් කපනකොට මදුළු ගලවද්දී මදුළු කියන්නේ මැද මේ the edible part ගලවද්දී මේ it's sticky. චූටි fibers එක it's sticky. That sticky part is what we call කොහොල්ල. ඒක ඉංග්‍රීසි වලින් කියන්නේ jack glue කියලා. Jack is කොස්නේ glue එක කියන්නේ because it's sticky. කොහොල්ල අතේ ගෑවුනම වතුරෙන් හේදුවට යන්නේ නැහැ. right? ඒක soap වලින් හේදුවත් යන්නේ නැහැ. මොකද soap මදි ඒක. චර්ටම sticky jack glue. ඒතර ගොඩක් වෙලාවට අපි කරන්නේ මේ පොල් තෙල් අරගෙන පොල් තෙල් වලින් තමයි coconut oil වලින් තමයි ආව අයින් කරන්නේ. Because jack glue is non-polar, coconut oil is also non-polar, so it dissolves in coconut oil. එතකොට තමයි අයින් කරන්න ලේසි. ඊට වඩා තවත් ලේසි if you have kerosene. භූමි තෙල් වගේ තියනවා නම් ඒ තවත් හොඳට යනවා. coconut oil වලත් ටිකක් අමාරුයි කියන්නේ. සමන යනවා. But ඊට වඩා ලේසියෙන් kerosene වලින් යනවා because kerosene is even more non-polar. So that is this last example I'm writing. Sinhala ලියාගත්තත් කමක් නැහැ. Is non-polar, coconut oil. මම coconut oil example එක දාන්නම්. Is non-polar. Therefore, it dissolves in coconut oil. පොඩ්ඩක් ලියන්න වැඩි මෙතන, but this is very important. That's why. ඉක්මනට ලියන්න ළමයි. අද PDF එකත් අපි කරන්න ඕනේ. Make it fast. For this, I will give you like 5 minutes. 5 minutes, 6 minutes then. Let's see if you need more time, I will give, but try to finish within 6 minutes. Make it fast. You have like a little less than 1 minute, lamai. Make it fast. Done writing, lamai? Who needs more
Yes,
time?
teacher.
Okay. Who needs more time? I'm gonna move on, lamai, yeah? Okay. Put a subtopic, solubility of a gas. Now, all this time we were mostly talking about solids and liquids, but we did not talk yet about gases. So put a subtopic, solubility of a gas. Solubility of a gas. Okay. Now don't write anything and just listen. What happens now? Okay, let's say you bought a frizzy drink from a store. Frizzy drinks can have example like either like Coke or Sprite, Pepsi, cream soda, Necto, EGB, whatever. Aragena, when you are trying to open the lid, let's say this is your frizzy drink bottle. When you are trying to open the lid, can you see that? Maybe gas bubbles put up me mudate yana dakala tiyana. Have you all noticed that? When you're trying to open the frizzy drink bottle, there are like tiny gas bubbles going up. Yes. Okay. What will happen if you shake this frizzy drink? Again, to shake karala. Shake karala bleed the carrier mukadde venne. Godak shake karala. When you open the lid, what will happen? What will happen? Yes. You take the carbonated or the frizzy drink. Moody wahala thedi on the shake karana. Shake karala moody arena. Mukadde venne. Aras gala villa. It go overflow, you know. Yes, it gets foamy and it overflows, right? Okay, so that is another observation. So it seems like you guys have the experience, you guys have seen this, or you have this observation. එතකොට ළමයි සාමාන්‍ය frizzy drink එකක් කොහොමද හැදෙන්නේ කියලා අපි බලන්න ඕනේ. Okay. Usually, now let's say for an example, Necto. Necto කියන drink එක ගත්තොත් එහෙම විශේෂයක් නෑ ඒකේ. මොනවාද තියෙන්නේ? Water තියෙනවා. Coloring මොන හරි තියෙනවා because of course they need to get that like magenta color. Then of course flavor මොන හරි තියෙනවා. පස්සේ මොන හරි preservatives මොන හරි තියෙනවා. Mainly තියෙනවා carbon dioxide. Yes. You know all frizzy drinks, Necto hari, Coke hari, Pepsi hari, cream soda, EGB මොනා හරි ගත්තාම හැම frizzy drink එකකම frizzy රහ තියෙන්නේ. They have this like unique taste. ඒ ටේස්ට් එක තියෙන ළමයි carbon dioxide dissolve කරලා තියෙන හින්දා. Now does carbon dioxide dissolve in water? දැන් මෙතන වැඩිපුරම තියෙන water නේ ඔය fizzy drinks හැම එකකම. Does carbon dioxide dissolve in water? Carbon dioxide water වල dissolve වෙනවා. Are you sure? No. Are you sure? What do we know about how carbon dioxide dissolves in water? Okay, yes. Actually, lamai, yes, carbon dioxide is non-polar, water is polar. So dissolve in and ඇත්තටම කතාව ගත්තොත් එimhe චුට්ටයි dissolve වෙන්නේ, very slightly soluble in water. So normal, I mean, polar non-polar පැත්තෙන් ගත්තොත් yes, it is no. But also grade 10 වල changes in water වල අපි කතා කරා carbon dioxide is slightly soluble in water. So ඒකද චුට්ටක් dissolve වෙනවා. පොඩ්ඩක් dissolve වෙනවා. එතකොට දැන් මේ carbonated drinks වල carbon dioxide චුට්ටක් dissolve වෙලා මදි. So carbon dioxide has to dissolve a lot. එතකොට මොකද වෙන්නේ? What we are going to do is when they manufacture these fizzy drinks in factories, they increase the pressure. Carbon dioxide පොඩ්ඩයිනේ වතුර වල dissolve වෙන්නේ. ඒගොල්ලෝ මොකද කරන්නේ? pressure එක වැඩි කරලා by force carbon dioxide ගොඩාක් බලෙන් dissolve කරනවා ඇතුලේ. dissolve කරවලා lid එක වහනවා. Okay, otherwise carbon dioxide is only slightly soluble in water. ඒක explain කරන්න පුළුවන් because as you said yes, carbon dioxide is non-polar, water is polar. ඒක නේ හරියට dissolve වෙන්නේ නැහැ. මාරම චුට්ටයි dissolve වෙන්නේ. එතකොට මෙතන මොකද කරන්නේ? අපි pressure එක වැඩි කරලා බලෙන් carbon dioxide water වල dissolve කරනවා. By force. Okay. ඊට පස්සේ colouring ඔක්කොම දාලා එහෙම තමයි fizzy drinks හැදෙන්නේ. So if you take a fizzy drink bottle, carbon dioxide is forcefully dissolved in this drink. Forcefully. Pressure වැඩි කරලා බලෙන් dissolve කරලා තියෙනවා. ඒකයි ඔයා lid එක අරිනකොට carbon dioxide වලට තේරෙනවා මට දැන් යන්න පාරක් තියෙනවා. Okay. ඒකයි මේ චූටි gas bubbles මෙන්න උඩට එන්නේ. Those little gas bubbles are actually carbon dioxide. Okay. What will happen when you shake this bottle? Shake කරද්දි මොකද වෙන්නේ? dissolve වෙලා තියෙන carbon dioxide ටික ඔක්කොම මෙතන මේ gap එකේ තියෙන air වලට move වෙනවා. If you take this bottle, here there's a little gap with air නේ. So whatever when you shake the bottle, the carbon dioxide dissolved in the water will jump out of the water and will get collected in this little space. ඒකයි lid එක අරපු ගමන් දැන් මෙතන ඔක්කොම carbon dioxide gas ටික මෙතන fill වෙනවා කියන්නේ that's a very little space no. Little space එක carbon dioxide ගොඩාක් fill වෙනවා කියලා කියන්නේ. lid එක අරපු ගමන් ඒ fill වෙලා තියෙන carbon dioxide ටික ඔක්කොම ගාලා උඩට යනවා. Right? So that is that, right? Up to that point, did you metan තේරුම් ගන්න ලොකු දෙයක් නෑ. It's based on the normal observations that we know. So as I said, fizzy drinks ගත්තොත් එහෙම water තමයි mainly තියෙන්නේ. Water වලට colorings, preservatives, flavors add කරලා තියෙනවා. So carbon dioxide is only slightly soluble in water, but in fizzy drinks they increase the pressure and they make more carbon dioxide dissolve in water. They make more carbon dioxide dissolve in water by increasing the pressure. So by force, ගොඩාක් carbon dioxide dissolve වෙලා තියෙනවා. ඒකයි අපි lid එක අරින්න හදනකොට චූටි gas bubbles මෙම උඩට යන්නේ. Because carbon dioxide wants to get out of the solution. ඒගොල්ලන් බලෙන් dissolve කරලා තියෙන්නේ. And when you shake the bottle, the dissolved carbon dioxide will jump out and get collected in this little space. That's why when you open the lid, it all goes out like that. Up to that point, is it clear to you? Eka තේරුණාද? හරි. ඒකටම related මම තව observation එකක් කියන්න. මම දැන් කඩේට ගිහලා ගන්නවා nectar bottle එකක්. මම සමහර nectar තමයි fizzy drinks වල කැමති. අරගෙන මම ඒක ටිකක් බොනවා. lid එක අරලා ටිකක් බීලා ඊපස්සේ මම ඒක මෙතන තියලා තියෙනවා lid එක open කරලා. I don't close the bottle again. I keep the lid open and I leave the bottle for, let's say, 3-4 hours. So හවස් වෙලා මම ආයෙ ඇවිල්ලා ඒ nectar එකෙන් උගුරක් බොනවා. Will it taste the same? Will it taste the same? No. පැය 3 කියන්නේ අරපු බොටල් එකක් අරලා තියලා ඊට පස්සේ පැය 3-4කට විතර පස්සේ ඇවිල්ලා ආයෙ ටේස්ට් කරද්දී it tastes very boring, right? It tastes very boring. නිකන් වතුර colouring කියන්නේ flavors දාපු වතුර එකක් බොනවා වගේ. Because that is what it is actually. Colorings, flavors, preservatives දාපු වතුර ටිකක් විතරයි. ඇයි ඒ? Frizzy drink එකේ ළමයි, as I said, carbon dioxide is forcefully dissolved නේ. මෙයාව ඇරලා ගොඩක් වෙලා තිබ්බම මේ carbon dioxide ටික ඔක්කොම දැන් pressure එකක් නැහැනේ. lid එක වහලා තියෙද්දි තමයි හොඳට pressure එක තියෙන්නේ. So if you keep the lid closed, carbon dioxide එක solution එකේ drink එකේ ටිකක් ඉඳී. But if you keep the lid open, all the carbon dioxide in the solution will escape to the atmosphere. The carbon dioxide එක escape වුණාම the drink will not taste the same. Okay. So I have a question. දැන් අපි discuss කරපු ටිකේ මම පොඩි ප්‍රශ්නයක් අහනවා. Does increasing pressure increase or decrease the solubility of a gas? When you increase the pressure, solubility of a gas, does it increase or decrease? I got one answer as increase. Another answer as increase. Okay. Let me rephrase the question. Let me explain the question again. When you increase the pressure, does the solubility of a gas increase or decrease? මට දැන් answers තුනක් ආව increase කියලා. What do others think? Yes, it increases. ඒකනේ මෙතන උනේ නේද? Frizzy drinks හදද්දි මොකද කරන්නේ in factories? How do they manufacture? Normally carbon dioxide is only slightly soluble in water. However, how do we make sure that more carbon dioxide dissolves? We increase the pressure and we pressurize the carbon dioxide into that water. Now, pressure is one of the factors that affect solubility. How does it affect solubility? It increases the solubility of a gas. Up to that point, is everything clear, Lamai? Give me a thumbs up. හරි එහෙනම් මේක මාත් එක්ක ලියන්න බලන්න. Just a few sentences, huh? So ඒකයි like pressure carbon dioxide අපි වැඩිපුර dissolve කරන by increasing the pressure no. When we open the lid of the drink, pressure එක එන්න අඩු වෙනවනේ. ඒතර solid carbon dioxide dissolve වෙලා තියෙන ප්‍රමාණයත් අඩු වෙනවා. That's why you can see gas bubbles of carbon dioxide coming out of the solution. Little tiny bubbles. ඔයාලා lid එක open කරද්දී pressure එක අඩු වෙනවා ඒකයි. and pressure වැඩි කරොත් තමයි යා dissolve වෙලා ඉන්නේ. That this is the story of pressure. Quickly write. Make it really fast. අද අපිට PDF එකට යන්න බැරි වෙයි because composition වල half cut කරන්න පුළුවන් වුණොත් බලමු අපි.
Teacher,
Yes.
do like wishes to today?
What is it, Ashita?
Like, are we going to do the notes in a tube? Like, you gave a tube for mixtures, right? For part 2.
Yeah, that's what I said. I'm not sure. I don't think we'll be able to do that today. We will complete this solubility of a gas without shuttai. Once we are done with that, we have to do composition. Composition halfway we might be able to do, but there's like a lot of calculations in that. So ඒකෙත් කොටසක් අපිට ඉතුරු වෙයි next week. So we'll do those next week. I have a feeling that we'll be able to finish mixtures next week. If all goes well, we'll see. Mixtures වලට පස්සේ ළමයි අපි කරන්නේ fourth එක පොඩ්ඩක් අපි skip කරනවා. Fourth එක skip කරලා අපි කරන්නේ fifth එක, which is geometrical optics, light. ඒකට note එකක් නැහැ. We have to handwrite the note. After that, we will do waves. Waves වලට note එකක් තියෙනවා. Today is January 17th. No. Let me know when you're done. ඔගාට තාම තේරෙන්නේ නැහැ, but we are on a bit of a කියන්නේ අපි චුට්ටක් fast යන්න ඕනේ. මොකද මම කියවනේ මේ ඔගාන්ට exams තියෙන December, right? එහෙනම් December exams තියෙන prepare වෙන්න නම් අපි August පළවෙනි සතියේ ඉඳන් වගේ past preparation එක පටන් ගන්න ඕනේ. So always keep that in mind. That should be the goal. So the මං හදිස්සර extra class එකක් දෙකක් වගේ දැම්මට don't be upset with me because අපි දැන් ඒ කියන්නේ අන්තිම මොහොතේ ගොඩක් rush කරනවට වඩා දැන් අපි rush එකේ rush මත් නෙවෙයි but if we try to speed it up a bit අන්තිම කාලේ අපිට stress එක අඩුයි. හරි. So that is pressure. So එතන highlight කරගන්න මෙන්න මේක. No, highlight නෙවෙයි. Let's just write one more sentence here. Therefore, when increasing the pressure, solubility of a gas increases. And Please highlight that sentence. That is very important. Yes, Cindy. Cannot see. Can you see now? Now? Sampai නැද්ද? Ena receive the connection issue එකක් වෙන මෙන්න මම මේ දැන් පෙන්න last sentence එක you can't see no? Can you try to rejoin? ඒ sentence එකට ඉඩ තියාගන්න. ඉතින් මම කොහොමත් ඒක whiteboard note එකේ වන්නම් but try to rejoin, maybe it's a connection issue. Okay, quickly. Receive the join වෙනකන් අපි පටන් ගමු. එයා join වුණාම I will tell her again. So there's another factor that affects temperature. ඒකට මම තව observation එකක් කියන්නම් that we encounter so many times in our day-to-day life. When you heat a vessel with water, one second. Risinda, can you see the board now?
Yeah, I can't move the board.
Hmm?
I can't like move the board. I can only see the notes.
Okay. How about now? Sorry, wait 1 second.
Okay, teacher, now I can see.
Okay. Others also can see now, right? Okay. So if I take a vessel of water and I heat it, then this will start to heat up, rath vela, and then it will start to boil. Boil again, you can see bubbles හැදෙනවා, right? අපි සිංහ කියන්නේ නටනවා කියලා. Boil වෙන පටන් ගන්නවා, there will be like bubbles forming. What are these bubbles ළමයි? මොනවද මේ bubbles කියලා යන්නේ? What are these bubbles? That's not water. That's not steam. Bubbles කියන්නේ steam නෙවෙයි. What are these bubbles?
The water vapor, like water droplets.
No.
Water vapor, like
Not water vapor either. Yeah. Okay. Actually, lamai now water vela gases dissolve velate now, you know. Hydrogen, oxygen, and carbon dioxide, all these three gases are slightly soluble in water. Can I dissolve now? It's not just those, there are many other gases, nitrogen, good gases in our atmosphere. So all these gases are dissolved in water. Generally, product dissolve velate. ඔයා boil කරද්දි මොකද වෙන්නේ? රත් කරද්දි මොකද වෙන්නේ? මේ gas bubbles gases dissolve වෙලා තිබ්බ gases, they will start to form bubbles and they will go out of the solution. So මේ bubbles කියලා කියන්නේ dissolved gases. So before you heat it, these gases are dissolved in water. But when you heat, it will boil, it will start to form bubbles and will escape the solution. So based on this observation, can you answer this question? Does temperature, when you increase the temperature, does it increase or decrease the solubility of a gas? Yes, Ashrita. I didn't hear you.
Increases.
I didn't hear. Decrease.
Okay, decreases. Sorry.
Decrease. Yes.
Yeah.
Yes. In the chat box also I got the answer. Yes. Hey, අපි temperature එක වැඩි කරද්දී dissolve වෙලා තියෙන කට්ටිය solution එකෙන් එළියට යනවා. That means temperature එක වැඩි කරද්දී ඒගොල්ලන් dissolve වෙලා ඉන්න කැමති නැහැ. That means when you increase the temperature, solubility of a gas decreases. So
Tisha, when we heat the water, the temperature decreases, no? Solubility of a gas.
when you heat, temperature increases, right?
Temperature decreases.
When you heat,
No, I came to ask like when we freeze the water, like
freeze, yes.
the
Temperature
solubility of the gas will decrease. No?
will increase. When you heat it, the solubility of a gas decrease. That means when you cool, solubility of a gas increases.
Okay, Tish.
Okay. Okay, let's start writing. So the first factor is pressure. The second factor, number 2, temperature. Last point better to highlight because that is very important. Quickly write this down. While you write it, give me 2 minutes. Done writing, lamai? Thumbs up, please. Others? Okay. So that is about solubility of a gas. And now we will move on to a completely new section. So आप मिचला solubility के गोड़ा खाता कराने. So now we are going to talk about something called composition. एक खाता कराने खाली. Let's put a topic. Composition of a mixture.
Teacher, you're stuck. Teacher,
Yes.
you're lagging.
Can you hear me now? I'll keep the camera off for a bit. Mama, can you hear me now?
Yeah, teacher, I can hear you.
Okay. Marat penno metana connection is unstable. So for a bit, I'll keep the camera off and see. Okay. Composition of a mixture kyane lamai. Now mixture, if you take a mixture, there are different components, right? There can be, there is one solvent. The component that is present in excess is a solvent. In addition to the solvent, there can be one or more solutes. ඒ වගේ components ගොඩක් එකතු වෙලා තමයි mixture එකක් හැදිලා තියෙන්නේ. So we need to have an idea about how much of each component is present. For an example, අඳින්න එපා මොනවද ලියන්න එපා. If I take 100 milliliters of water, 100 milliliters, let's get 100 grams of water. And I dissolve 3 grams of NaCl. Now, මෙහෙම values දුන්නා අපි දන්නවා, okay. මේ mixture එකේ, if you take this salt solution, there is 3 grams of NaCl, there is 100 grams of water. Likewise, in any mixture, you need to have an idea about the amount of each component present. So, ඒක අපි express කරන විදි පහක් තියෙනවා. There are 5 ways how we can express how much of each component is present in a mixture. First method එක තමයි composition as a mass fraction. ඒකෙදි අපි මෙහෙමයි කරන්නේ. So, mama, real life examples නැතුව hyper can I just I'll just take some examples like this. Let's say I have a mixture. මේ mixture එකේ components දෙකක් තියෙනවා. Let's say A and B. So there could be more than 2 components. There could be another one as C, another one as D. ඕන තරම් තියෙන්න පුළුවන්. So here in this example, there are only 2 components. So one is definitely the solvent, other one will be the solute. අපි කියමු මෙතන තියෙනවා A වලින් තියෙනවා let's say 12 grams. B වලින් තියෙනවා 48 grams. මෙතන mass fraction එකක් කියලා කියන්නේ ළමයි. අපි මෙන්න මෙහෙමයි. Now let's say for an example, let's take A. How do we write the mass fraction of A? We take the mass of A and we divide that by the total mass. You know what is the total mass here? Mass of A plus mass of B, right? So mass fraction of A kiyanne, you take the mass of A and you divide that by the total mass. So mass of A is 12 grams. Total mass kiyanne 12 grams plus 48 grams. So that means 12 grams divided by 12 plus 48 කියන්නේ 60 grams. බලන්න මෙතන grams cancel වෙනවා. 12 times 1 is 12, 12 times 5 is 60. So the answer is 1/5. This is the mass fraction of A. Did you all understand that? Thumbs up, please. මේකේ මට උනා B වලත් mass fraction එක කියන්න පුළුවන්. කොහොමද mass fraction of B කියන්නේ? It's very simple. You take the mass of B and you divide that by the total mass. So if you take mass of B is 48 grams. Total is 12 plus 48, which is 60 grams. Here grams cancel වෙනවා. 12 times 4 is 48. 12 times 5 is 60. So you get the answer as 4/5. Is that clear, Lamai? Thumbs up. Excuse me. Okay. So there is no unit here. Okay. මේක ලියාගන්නවද ළමයි? So mass fraction means හැමලේම අපි whatever the component it is, you take that mass and you divide that by the total mass. That's how you get the mass fraction of each component. Quickly write this, Lamai. Ashwita, can you hear me?
Yeah, teacher, like for before I couldn't join the meeting. Suddenly, the class stopped, and then I couldn't join. That's it. I called you, teacher.
Yeah, so that's probably because of a connection issue. මට පෙන්නුවා මෙතන drop වුණා කියලා, but anyhow, the waiting room is disabled, so you can join anytime. Must have been a connection issue. Now, okay,
Okay.
Nene?
Yeah, yeah.
Okay, quickly write this then. Quickly write.
Teacher,
Yes, Ashwita.
did you say anything? Like to write this?
Yes, this one. Mass fraction clinical, yeah.
Okay, teacher.
Okay. Make it fast. I'll give you like 3 more minutes, Samaya. Yeah?
Teacher, at what time the class will finish?
Today we'll finish the class after this part. I said we will finish at 9:45. But for today, we'll stop next week up at 9:45 varakum.
Okay, teacher. No,
Because
because
last
I
week we
asked.
stopped, we started 1 hour late, no?
Because I asked because we are having a house meeting today.
Ah, right, okay. So once you write this, you can leave.
Our heats and all are coming like on the next coming week. So like they told we will be having a house meeting today after 9:30.
Ah, right. Ah, you mean house meeting as in school, no?
Yeah,
Other
yeah, it is.
in your house, people
So
meeting. Okay,
house meeting.
okay.
Done, teacher.
Okay. Ashwita, you can leave. What about others? Have you all finished? Others? Mayumdi, Metmi, Metna, Rashmika, Yashoda. Okay. We will stop here today, Lamai. So next week we will do the rest of the 4 methods. I told you there are 5 methods altogether. We have a whole lot of calculations to do in this lesson. Ekata, I want you all to give a little homework, not like that, not exactly homework, kind of like something for you to do as an activity is revise the quantification lesson and count. Grade 10 7th lesson quantification, relative atomic mass, relative molecular mass, molar mass, then N equals MOM, so a lesson revise again before you come to next week's class, because next week quantification goda kata karna, because we are going to do chemical calculations. Okay, so I will send you the whiteboard note. When it comes to what we did today, is everything clear? Do you all have any questions? Or is everything clear? Give me a thumbs up if everything is clear. Mayumdi, Evindi, Rashmika, Desindu, Yashoda. Hare. Next week, we have the class on 21st. Arame print out aragate neti kattiye print out karang enna aniwaryen. We have the class on 21st. And yeah, so no other homework, just revise the quantification lesson and come. And we'll see each other next week, Lamai. So until then, have a great week and good night. Okay.